Hi, so I've been asked by one of the boys in year 8 to do this question. So it's paper 1, question 5. So how many circular discs with radius 3 centimeters can be cut from 1 square meter of steel? So 1 square meter, that's 1 meter multiplied by 1 meter, okay? 1 meter wide, 1 meter long. Okay, so let's just draw that first. Remember, I always tell you, draw the thing. Although not many of you actually do it. So I'll just color this in for you so you can see what's going on. All right, fine. So it's going to be something like this. Oh, actually, I'll just make it a bit neater. There you go. Something like that. Okay, so it's going to be 1 meter across and 1 meter down. Now, we have centimeters here for the circles, the discs, and this is meters. So let's convert that all to centimeters, so we're all in the same unit. So 1 meter is 100 centimeters, so it's 100 across, and it's 100 down. Okay, cool. Now we're told each circle is 3 centimeters, okay? So you're going to have some kind of a circle cut out of this, and it's going to be 3 centimeters in radius, which is 6 centimeters in diameter, right? So you're going to get all these circles, and we're just going to cut it out, and then cut another one out, and etc. So how many of them circles can we cut out of this? So, well, if we put them all like right side by side and went across, how many would there be? So this is not to scale, right? I'm just showing you this as a schematic. So it's just an example of how it works, not necessarily to scale. So what we do is, if each circle is 6 centimeters across, because the radius is 3, how many 6s can you fit in 100? So it's just 100 over 6, and that'll give you 16.666, okay? And that just is recurring. So we can fit like 16 of them, whatever, really closely across, okay? Not like that, but just in that manner. And then how many can we fit down? Well, obviously it's going to be the same, right? It's just going to be 100. So this is going to be how many across. This is like how many down? 100 over 6. It goes 16.666, right? Now, we can't have 0.66 discs. We want to know how many full discs. So we can actually fit 16 full discs across, and we can fit 16 full discs down. Okay, so what that will actually look like is, here's one I made earlier. It'll look like, let's go right to the edge. Yeah, it looks something like that. Okay, fine. So we have 16 discs going across. So there's 4, 8, 12, 16, and 16 going down. So what's the total number of discs? Obviously it's going to be 16 times 16, right? So we just get 16 times 16, and that equals 256. So we can fit, if you count them, if you're really bored, count them, and you'll get 256. Now there is a kind of a, what would I say? You could be kind of fooled into thinking, well, if I just get the area of one circle, which is just pi r squared, right? Pi r squared, which equals pi times 3 squared, which is just 9 pi, right? That equals just 9 pi. So if I get 9 pi and divide that into 100 times 100, that'll give me my answer. Yes, it would, but we have to look at the practical side of this. If you're to cut out a circle, you're going to have this bit as waste. You can't make a circle. See these little blue diamonds? You can't make circles out of them because the circles are too big. Yeah. Now you could say, well, we could get that leftover waste and melt it down, and then make a new sheet out of what's left, and then get the circles. Yeah, you could do that, but you're always going to have that waste. Okay. So this question actually wants you to look at the practical side of that. When you cut these circles out, you're going to have this waste area, and we can't melt it down and then make a new sheet and take more circles out. That's just waste, and we can't use it. So that's why we can't just get like 100 times 100, 100 times 100. That's the total area divided by the area of each circle. That won't work, okay? Because we have this waste that is unusable. It's unusable waste. Okay, fine. So that's the first bit done. Secondly, calculate the area of the wasted steel. Well, I think everybody can probably do that now. So you just get the blue area minus the red area. So the blue area is 100 times 100. So 100 times 100. And we're going to take away the red area. So we have 256. Yeah, we have 256 circles, and we said each circle is 9 pi. So it's 256 times 9 pi. I'm not going to ask you to do that in your head. So when you do that on your calculator, right, what you should get is, I think it's 26. Just actually let me just check. I'll just double check this. It is the answer in the booklet. See, even I can't do this in my head. Well, maybe I could if I tried. Anyway, here we go. So it's 10,000 minus 256 times 9 times pi. So you just use the exact value for pi. Well, whatever your calculator's most precise value for pi, and it's 2761.77. Okay, so it's 2761.77, and that's it. How many decimal places did they ask for? How many circular discs? Yeah, calculate the area. Just go to 2 decimal places. Fine. And obviously that's centimeters squared. Cool. That's it. If you want to do that in you just leave it as that. If you want to do that in meters squared, you divide it by 100 and then divide it by 100 again. It's actually 0.276177 meters squared. So that's it. So that's your answer there, and your answer to part 1 is this. I'll put this up on Google Classroom, and don't ask me any more questions. No, I'm just kidding. If you're stuck, I'll help you if I can. I'm busy doing other stuff, like eating donuts. No, just kidding. Anyway, have a good night, and I will talk with you later. Bye.